system is very early stage, so it's the pre-production system. We were basically getting one of the first chip from the factory. We were assembling this one, especially for the SIGGRAPH. So this is really like one of the very early stage of the hardware, but still the demos we're showing here are very impressive, considering what you know from the mobile space. So not sure you remember our GTC event from March, where we are basically showing same demo called FaceWorks, running on a GTX Titan class hardware. So it was like really 250 watts powerful graphic card, and just a couple of months after, we were able to scale demo down to run it in the almost same quality on the mobile hardware. So what you see here now, it's a character called IRA, and we are using for the rendering OpenGL 4.3. And of course, we're using partially tessellation and as well as some high-end techniques you know from a PC. So for example, I can show you my favorite one. So look at the ear. You know, the light is coming to the ear or the skin. This technique is called the subsurface scattering. So it basically helps you to show realistically light coming through the skin. So this is one of the feature which is known from big PCs, and we basically coming with this one to the mobile space. I think it's pretty impressive what you can achieve. Imagine that we basically said that the mobile Kepler is coming in a product in the first half of next year. So imagine that you could show it to your friends, this demo, on your mobile phone, like maybe in the next year. So it's pretty impressive in compare where we are now, where we were a couple of years ago. So let's kill the demo and we can move to the other one. This demo is called Island, and I'm using a demo mostly for demonstration of tessellation. So what you see here, it's basically a landscape of water. It's a nice island. It's relatively high detailed model. Here you see amount of the polygons we need to render plus the frame rate. So let me stop the demo that I can basically show you the island. So let me move in that direction and I will switch on wireframe model. So you see that amount of polygons we need to render is pretty high, and it's very smooth because we are using tessellation here, and the tessellation is basically working in a way that you need to, or it's helping you to render the objects you see, but the objects you don't see, it's basically making much more simpler. So you can in that case render such an amazingly detailed landscape, and you can still do it in very high frame rate. Imagine if I disable the tessellation, then you are immediately dropping a frame rate between the 200 to 300%, from 30 frames to 10 frames, because the amount of triangles and the polygons you need to render are much higher. And then of course the system is like overloaded, and you see that the frame rate is very slow, because now we basically render every single object in the screen, even the one is very far away, you don't see. So that's basically the miracle of tessellation, that this can help with such kind of the scene. So now I enable the tessellation again, and you see that the amount of frames are immediately increasing back to the 30, and it's very fluent. So theoretically, imagine that in the future you can really bring the big games, you know, from the PCs to such small devices like phones or tablets, and in the same quality, especially because of technologies like tessellation or what we were showing in the previous demo. So that's the one I wanted to show you, and then basically that's in summary it's everything what we have here. So I could really recommend you now to just go and check the systems. Maybe to show you one more